In this video, we are going to talk about polygons. A polygon is a closed shape made of straight line segments. Let's start with common examples. A three-sided polygon is called triangle, like this. It's closed and made of three straight line segments. So it has three sides. It's called triangle. A four-sided polygon is called quadrilateral. If it's like this, it has four sides. It's called quadrilateral. To help you to remember, quad means four. Here are some common quadrilateral polygons, like a square, which is look like this. It has four right angles. Each angle is 90 degrees and equally sides. So a square has four equal sides and four right angles. So this shape is called square. Another shape is rectangle. It looks like this. It has four right angles like square. And equal opposite sides. So this here equal to this. This here equal to this. This called rectangle. Another shape is rhombus. It looks like this. It has equally sides and equal opposite angles. So this here called rhombus. Also, a square, rectangle, and rhombus have parallel opposite sides. Like, I will change the color, like this one parallel to this one. I will draw it like this. And this one here, it's parallel to this one. So this side parallel to this side, this side parallel to this side. And the same thing here, this parallel, I will put two symbol here like this, and this parallel to this one. And the same thing here, this parallel to this parallel to this one parallel to this one parallel to this. Another shape is parallelogram, which look like this. I will change the color, which look like this. A parallelogram has equally opposite sides, like this one equal to this one. I'll put two symbol, and this one here equal to this one. Also, this side parallel to this side parallel to this side. So a parallelogram has opposite sides are both equal and parallel. Also, it has equal opposite angles. This angle equal to this angle, and here this angle equal to this angle. So a parallelogram has opposite sides that are both equal and parallel, and opposite angles are equal. This called parallelogram. Let's go down. Another shape is trapezoid. It looks like this. A trapezoid has a pair of parallel sides. For example, if this side parallel to this side, this called trapezoid. Trapezoid. So as the number of sides increase, polygons have special names. I will tell you another name. If it is a 5-side polygon, is called pentagon, like this. It has 5 sides. It's closed and made of straight line segments. This is called pentagon. If it has 6 sides like this, it's called hexagon. If it has 7 sides like this, it has 7 sides like this, 1, 2, 3, 4, 5, 6, 7, 7 sides, it's called heptagon. If it has 8-sided polygon, it's called octagon, like this. 1, 2, 3, 4, 5, 6, 7, 8. So this is octagon. Eight sides. If it has 9 sides like this here, for example, like this, then like this, then like this. 1, 2, 3, 4, 5, 6, 7, 8, 9. It has 9 sides. 1, 2, 3, 4, 5, 6, 7, 8, 9. It's called nonagon. If it's a 10-side polygon like this, it's called decagon. It has 10 sides, of course, and 10 angles. 10 side, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. How it has 10 angles? You can count this one as 1 because here it's more than 180 degrees. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it has 10 angles. Now let's go down. Now let's define clearly a polygon. A polygon, I will speed it up to write a polygon is a 2D closed shape made of straight line segments. So I will speed it up. So this is a definition of a polygon. A polygon is a 2D closed shape made of straight line segments. As you can see here is 2D. 2D means it has only length and width, no depth. If a shape has depth like a cube or cuboid, it's called a polyhedron, not a polygon. So to be a polygon, a shape must be closed shape made of straight line segments like this here. It's a closed shape made of straight line segments as this shape, and also it has to be 2D. 2D, it's mean two-dimensional shape. Now let's go down. Let's answer this question. Is this shape a polygon? For example, if I draw for you a closed shape with straight line sides like this, is it a polygon? Yes, it is a polygon. Yes, it is a polygon. If I draw for you an open shape with 3 straight line segments like This is not polygon because it's not closed, so no. Why? Because it is not a closed shape. No, because it's not a closed shape. Or you can say it's open shape. Now I will draw for you a closed shape made of two straight sides and one curve like this. It's look like ice cream, and here it's curve. So this is not a polygon because it has a curve. No, because I will copy this one here. I can write it's not a made of straight line segment, but in this here I will write no because it has a curve. Curve. Another example, I will go down. Another example, I will draw a closed shape made with 5 straight sides like this. Of course, this is a polygon because it's made of 5 straight line segments and it's closed, and of course it's 2D. So yes, it's a polygon. Now I will draw an open shape with 5 straight sides like this, exactly similar to this one, but it's open. So this is not a polygon because here it's open. So I can write here, no, it's not a polygon. Why? Because it's not a closed shape. Or you can write, no, because it is an open shape. Another example is a circle. Is it a polygon? No, because it's made of a curve. So no. Why? Because it's made of a curve. Now, let's briefly talk about a complex polygon, also called self-intersecting polygon. A complex polygon is a 2D closed shape made of straight line segments as we have defined it before, as we have defined it here. I will copy it. I will copy it because it's almost exactly like this one. So I will copy it and I will put it here. But I will just change a polygon. Just I have to change it to complex polygon. So just I will change this polygon to a complex polygon. So let's delete this. Here I will write a complex polygon is a 2D closed shape made of straight line segments, but I will just put here comma, but at least one pair of its sides cross each other. So exactly similar as before, but here we add but at least one pair of its sides cross each other. Before they called it simple polygon, but here in complex polygon at least one pair of its sides cross each other. For example, if we have two triangles like this, but it cross each other like this, so they cross each other at here this point, so it's closed shape. You can see here it's closed shape made of straight line segments, and also it's 2D, but its sides here cross each other. So this is complex polygon. Another shape which is not complex polygon if it's like this. Almost exactly same as this one, but here it's not close. So this is not a complex polygon. Or you can say not even a polygon. So this is not a complex polygon, and you can say this is not a polygon. So before here, these type here, they called it a simple polygon. So this it's called, you can call it, if you want to be more specific, simple polygon. Here, this one is simple polygon, this one simple polygon, but this one is a complex polygon. Okay, in school level geometry, we usually focus on simple polygon, not a complex polygon, because they follow different rules. For example, the sum of interior or exterior angles in a complex polygon can be different, and that's not focus of this video. So when we talk about the sum of angles in a polygon, we are referring to simple polygon, not complex polygon. Now let's talk about 3D shape like a cuboid. For example, if we have like this, is this a polygon? No, it's not a polygon. Why? Because it's not a 2D shape. A 2D shape. They called it polyhedron, but not a polygon. So this here, it's not a polygon. It's a polyhedron. This here, not a polygon. They called it this here, they called it polyhedron. So this is a polyhedron, not a polygon. Now let's talk about regular and irregular polygon. A regular polygon has all sides equal and all angles equal. Let's write the definition here. Let's speed it up. So a regular polygon has all sides equal and all angles equal. For example, this triangle, if this angle here equal to this angle equal to this angle, and this side equal to this side equal to this side, this is regular polygon. Or you can say regular triangle. If it look like this, for example, a rectangle like this, if this angle equal to this angle, right angle, right angle, right angle, 90 degrees also. So if this equal to this, or I write it like this, and this one equal to this one, is this regular polygon? No, it's not regular polygon. Why? Because all sides here are not equal. This one, it's not equal to this one, so this is not a regular polygon. Let's draw another example, which is rhombus. In rhombus, this equal to this equal to this equal to this, and here this angle equal to this angle, here this angle equal to this angle. Is it a regular polygon? No. Why? Because all angles are not equal, because this angle not equal to this angle, so not regular polygon. Now let's go down. Now let's talk about the sum of interior angles in a polygon. Now let's write the formula. Let's speed it up to write the sum of interior angles of a polygon equal to the formula of the sum. Now, the sum of interior angles of a polygon equal n minus 2 multiplied by 180 degrees. So this is a formula to compute the sum of interior angles. N here represent as a number of sides. So if you want to find the sum of interior angles of three-sided polygon, you have to here to substitute here n equal to 3. Now let's write it here again, the sum of interior angles of three-sided polygon equal, I have to substitute instead of n 3, so it will be 3 minus 2 multiplied by 180 degrees. We know 3 minus 2, which is 1, 1 multiplied by 180 degrees, which is 180 degrees. If we have the sum of interior angles of not three side, if it's four-sided polygon, it's equal here. Instead of n, we have to substitute here 4. So 4 minus 2 multiplied by 180 degrees. 4 minus 2, which is 2. 2 multiplied by 180 degrees, which is 360 degrees. The same thing, the sum of interior angles of five-sided polygon equal, instead of n, we have to write 5. 5 minus 2 multiplied by 180 degrees, which is 5 minus 2, which is 3. 3 multiply 180 degrees. We have already multiplied 2 multiply 180 degrees. So here, since 3 multiply 180 degrees, so we have just to add 180 degrees to this one. So 360 degrees plus 180 degrees, which is 540 degrees. Again here, the sum of interior angles of six-sided polygon equal, instead of n, we have to substitute here 6. 6 minus 2 multiplied by 180 degrees. 6 minus 2, which is 4. 4 multiply 180 degrees. We have to just add 180 degrees to this one, so it will be 720 degrees. The sum of interior angles of seven-sided polygon equal, we have to substitute here 7, so 7 minus 2 multiply 180 degrees. 7 minus 2, which is 5. 5 multiply 180 degrees. As you can see, we have increasing from 1 to 5. 1, 2, 3, 4, 5. So every time here we multiply 180 degrees by this number. 1 multiply by this, 2 multiply by this, 3 multiply by this, 4 multiply by this, 5 multiply by 180 degrees. So we have just to add here 180 degrees. So 700 plus 100, which is 800. 20 plus 80 equal 100. So 100 plus 800, it will be 900 degrees. Now let's draw from three-sided polygon, which is triangle, to seven-sided polygon, which is heptagon. So I will draw them. So I will speed it up to draw them quickly. Since it has three sides, so the sum of interior angles of this 180 degrees. As this one, since it has four sides, so the sum of interior angles of this four-sided polygon is 360 degrees. And here, since it has five sides, 1, 2, 3, 4, 5, so here the sum of interior angles is 540 degrees. As this one here, if it is six-sided polygon, like here, 1, 2, 3, 4, 5, 6. The sum of interior angles is 720. So 720 is the sum of interior angles of this shape. This has 1, 2, 3, 4, 5, 6, 7 sides. So the sum of interior angles of this seven-sided polygon is 900 degrees. So 900 degrees. So as you can see, every time we add 180 degrees from here, this triangle, to this seven-sided polygon. Now let's take example about this. Let's give you example. Let's say you have this shape, and if here equals 60 degrees and here 50 degrees, and we want to find this x. How to find this x? To find this x, we know the sum of interior angles of a triangle is 180 degrees. So we know here the sum equal 180 degrees. So you can say x plus this equal 180 degrees. So x plus 50 degrees plus 60 degrees equal 180 degrees. Since this one equal 110 degrees, okay, so x equal, we take this one to the other side, so 180 degrees minus this 110 degrees. So therefore x equal 180 degrees minus 110 degrees, which is 70 degrees. So we found this x as 70 degrees. Now let's give you another example. If we have like this, if this 130 degrees and here 130 degrees, we want to find this x and here this x. So we know the sum of interior angles of this four-sided polygon is 360 degrees, as we wrote here and we wrote here. We know the sum equal 360 degrees. So we can write x plus this equal 360 degrees. So x plus 130 degrees plus 130 degrees equal 360 degrees. We know this here equal 260 degrees. So x plus x equal 2x, and if we take this one to the other side, so here I write equal 360 degrees, which is this one, minus this one, which is 260 degrees. So 2x equal 360 degrees minus 260 degrees, which is 100 degrees. Here if we divide by 2, and here if we divide by 2, this one goes with this one. So x equal 100 degrees divided by 2, which is 50 degrees. So we found this x as 50 degrees, and the same as this here, which is 50 degrees. So we have used the sum of interior angles of a polygon to find the missing angles here, x, and here this x. Now let's give you example about regular polygon. For example, if we have like this, if this equal to this equal to this, and the missing angles here x, and here x, and here x, and if we have missing exterior angle also here y. As we know, the sum of interior angles of this triangle is sum equal 180 degrees. We know the sum of interior angles of this triangle is 180 degrees, so we can use that to find this x. So x equal, we can immediately find x by divide this by 3 because they are equally angles. So we can say sum divided by n. N is 3. So since we know this, the sum is 180 degrees, we divide it by 3 because we know the sum is 180 degrees and we know that these angles are equal. So we have just to divide 180 degrees by 3. So 180 degrees divided by 3, it's like 18 divided by 3, which is 6, and we put 0 here. So here this x is 60 degrees, and the same thing here, 60 degrees, and this one 60 degrees. Now to find this y, it's very simple. We know this equal 180 degrees. So to find this y, we can say 180 degrees minus this 60 degrees to find this y. So y equal 180 degrees minus 60 degrees, which is 120 degrees. Or you can find it in another way. Since we know each exterior angle is equal, and we know the sum of exterior angle of any polygon is 360 degrees, so we can find y by, say, 360 degrees divided by n, which is here 3, because here we have 3 exterior angle in here and in this vertex and in this vertex, so that's why we divided by n. So 360 degrees divided by 3, and we know 36 divided by 3, which is 12, and we put here 0. So you can find it by this way or this way. As you can see, this one here equal to this one here. Another example, I will put here regular pentagon. I will draw it like this. If this one here equal to this one, equal to this one, equal to this one, and equal to this one, and here the missing interior angles, and here the missing exterior angle. To find this x, we know that the sum of interior angles of a pentagon is 540, or you can find it from here, or we can write the sum again here, the sum equal n minus 2 multiplied by 180 degrees. We know here this n is 5 because it has 5 sides, 1, 2, 3, 4, 5. So 5 minus 2, which is here 3. So 3 multiplied by 180 degrees, which is 540 degrees. To find this x, we know the sum of interior angles is 540 degrees. We can divide it by 5 to find this x. So x equal sum divided by n, sum equal 540, and n equal 5 because it has 5 sides. 540 divided by 5, we can split 540 to 500 degrees divided by 5 plus 40 degrees divided by 5. So 500 degrees divided by 5, which is 100 degrees, plus 40 divided by 5, which is 8 degrees. So the answer here is 108 degrees. So we found this x here as 108 degrees. So each angle 108 degrees. To find this y, it's very simple. We know this is a straight angle. We can say 180 degrees minus this x, this 108 degrees, to find this y. So y equal 180 degrees minus this 108 degrees, which is 72 degrees. So we found this y as 72 degrees. Or you can find this y by, say, the sum of exterior angles of this a pentagon polygon or any polygon is 360 degrees divided by the number of the sides. Since we know the sum of exterior angle of any polygon is 360 degrees divided by n, because it is a regular polygon. Since it is a regular polygon, so we can divide 360 degrees evenly by the number of the sides. So 360 degrees divided by 5, because it has 5 sides. 360 degrees divided by 5, it's like 350 degrees divided by 5 plus 10 degrees divided by 5. We split 360 degrees to 350 degrees plus 10 degrees. So the answer of this one, 35 divided by 5, which is 7, and we put here 0. Let's go right. So here plus 10 divided by 5, which is 2 degrees. So the answer is 72 degrees. So exactly the same as here. So you can find it by this way or this way since it is a regular polygon. I hope this video made Polygon easy and interesting to understand. If you found this helpful, please like, share, and subscribe for more math videos. Feel free to comment below if you have any question or suggestion about this video. Thanks for watching and see you in the next video.